Okay, this is on linear functions. Now, in the past, we've talked about linear equations. Equation of a line is in this form. And, x can be, it's called the independent variable. It's where we can choose anything for x. And y is called the dependent variable because it can only be whatever x turned out to be. I mean, you can only get y by whatever x is. Now, in a later section, what we'll talk about is the x's, the independent variable, will be something called the domain, and the dependent variable will be something called the range. But I will talk about it in this section. Okay, but now, instead of the equation of a line, what we're going to do is introduce a linear function. Now, in order to do the linear function, we're going to have special notation called function notation. Okay, function notation, let me change color right quick. Function notation is written like this. Now, that's not multiplication. How you read this is f of x. And x can be anything. So, the function value is what you get when you plug x into the function. Now, other letters can be used except x and y. Here are the most common ones that are used. Now, also, it doesn't have to necessarily be an x. It could possibly be a p or a q or anything inside the parentheses, but the letter on the outside can't match what's on the inside. Okay, so the linear function will be written like this. Now, if you notice, it looks almost exactly like the linear equation of a line up top. The only difference is the f of x is where the y is. So when we have the f of x in there, we call that a function. When we have y in there, it's just an equation. It's exactly the same thing. With the function notation, what we're going to be doing is evaluating the function. And that means plugging numbers in for x and simplifying. All right, here's a couple of examples. Here is a linear function. Now, in order to do these, I have to know what to use for x. Now, how it's written will be like this. You will have a number or something inside the parentheses. What's inside the parentheses is the x that you plug into the function. So here is f of 2. Everywhere the x is, I'm going to put a 2. Now, there was only one x in here, so that's all we have. Then we simplify that, and we get 10. 6 plus 4 is 10. Now, what this means, how you interpret that is, when x is 2, the function value of 2 is 10. Now, not only does it tell me that information, but it gives me a point I could actually plot on a number line. Now, since x is 2, the y would be 10. So how we, this is f of 2 equals 10 is the point 210. So f is x, 10 would be our y that we would plot on the number line. Here's another. Let's find f of negative 5. So we're going to plug negative 5 in everywhere the x is and simplify. Simplify that, we'll get negative 11. That means f of negative 5 equals negative 11, or the function value at negative 5 is equal to negative 11. And that also gives me the point I could plot. Now, I'm not necessarily concerned about the points, but we could plot these if we knew the points. All right, here's another example. F of x equals negative 2x plus 9. Here I want to find f of 1. So, a 1, I'll plug it wherever the x is. I'm going to get positive 7. So, my function value at 1 is 7. which can be represented as the 0.17. Alright, let's plug in negative 10. Let me find negative f of negative 10, so we'll plug in negative 10 everywhere the x is. You can get 20 plus 9 is 29. So the function value of negative 10 is equal to 29, which in point form would be negative 10, 29. And I look at the next example. It wants me to find f of a. Now, sometimes you won't have a number in the parentheses. You have a variable or a binomial or something. But it doesn't matter what's in that parentheses. You're going to put it where the x is. So look here. I'm looking for f of a. That means I put a everywhere the x is. And when I simplify, I get this. Now, I can't really do anything else with it, but that's a new function with the x replaced with an a. Alright, now, here's some more examples. I want to do, well, I'll just do a couple of them. Let's do number 1. Whoops. Whoops. I have no idea what just happened. Let's erase this. Okay. So let's do number 1. Working with function f, and we want to find f of 2. So we want to put a 2 where the x is, and we're going to simplify. So it's 7 minus 10, which is negative 3. So the function value for positive 2 is negative 3. Let's do one involving g. I'll do we'll do number 6. Why not? Alright, number 6. We're using function g equals 2x minus 3, and we want to find the function value for negative 3/4. So everywhere the x is, I put negative 3/4 minus 3. Okay, whoops, hold on, y'all. Number 6 is 2.5. I looked at the wrong thing. So let's go back. 2.5. 2.5. So the 2.5 now goes where the x is. Simplifying that, we'll get 5 minus 3, which gives me 2. So the function value of 2.5 is equal to. Alright, I'll look at number 10. It wants us to take g, and in the place of x, it wants us to put k squared. So let's just see what that's going to look like. So we're taking function g, and we're going to put a k squared everywhere the x is. So we just end up with 2k squared minus 3. There's not really much I can do with that. Later on, and there'll be some special stuff we'll be able to do when plugging something in other than a number. But you just plug whatever's in the parentheses in for x and simplify.